Hi, a very good morning, everyone. I welcome you all for the subject Applications of Electronics Engineering, that is for the fifth semester. So, today we will discuss the first chapter, that is Consumer Electronic Devices. My name is Ishwar Kumar Nerade, working as lecturer in ENC department, Government Polytechnic, Modod. So, let's start the first chapter. So, in this chapter, we will be discussing the very first one, that is we will be introducing the concept of consumer electronic devices. Then, among them, for your syllabus, we will be discussing the various types of consumer electronic devices which will be which are introduced in your curriculum. Like the very first one, we will discuss the calculator and its operation. Then, microwave oven, washing machine, air conditioner, refrigerator, barcode and QR code, and the office automations, the features of office automation tools. Okay. First of all, what do you mean by a consumer electronics? So basically, the consumer electronics, it refers to any device, any electronic device that consists of an electronic circuit board in it. So whose intention is to serve the purpose of an individual for everyday usage of an individual. Their intention is to serve the purpose of an individual for everyday usage. ಸೊ ಅಂದ್ರೆ ಅದರ ಅರ್ಥ ಏನಪ್ಪಾ ಅಂದ್ರ ಯಾವ ಡಿವೈಸಸ್ ಒಳಗೆ ನಾವು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸರ್ಕ್ಯೂಟ್ ಬೋರ್ಡ್ ನ ನೋಡ್ತೀವಿ. ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸರ್ಕ್ಯೂಟ್ ಬೋರ್ಡ್ ಅಂದ್ರೆ ಏನು? ಬೇಸಿಕಲಿ ಇಟ್ ಮೇ ಬಿ ಎ ಪಿಸಿಬಿ ಇನ್ ದ ಸೆನ್ಸ್ ಪ್ರಿಂಟೆಡ್ ಸರ್ಕ್ಯೂಟ್ ಬೋರ್ಡ್. ಸೊ in any device, if you find an PCB board in it, and whose intention is to serve a purpose, particular purpose, such a device is referred as consumer electronic device. For example, the various consumer electronic devices which will serve a purpose in day-to-day use are the very first one is television. So basically, it will give you the television TV, so which will give you audio as well as visual information to the viewers. Digital cameras to get any stills or photos. Calculators, these are for the mathematical operations. Computers, tabs, laptops, so which will do the processing operation, as well as they take the input from the users as well as produces the output through some display devices. Music systems, so these will provide or these will serve an entertainment, these will serve for the entertainment purpose. Digital clocks, so which will show the timing informations. The headphones, these are for the again for the entertainment purpose. Washing machine, microwave oven. Microwave oven, as you know, these are for the cooking and reheating the foods. These are used for the cooking and reheating of the foods. Refrigerators as well as the air conditioners. So basically, these consumer electronic devices make the life of an individual in a luxurious to lead in a luxurious manner. So first we shall introduce the very first consumer electronic device, that is calculators. What are calculators? So calculator is a small portable electronic device which is used to perform calculations, as you know that. So in most of your classes or in most of your labs, for the basically the calculators are used for the calculation purposes. The calculations may range from basic arithmetic operations till the complex mathematics. ಇದರ ಅರ್ಥ ಏನಪ್ಪಾ ಅಂದ್ರೆ the calculations may range from simple addition, subtraction, multiplication or division till any scientific calculations. You can do the all range of calculations by the calculator. And it is a portable electronic device. Portable electronic device in the sense it won't be an heavy one. It won't be a heavy in weight. You can take it wherever you wish. You can put it in your pocket. Wherever you can go, you can take along with you. So these will serve, these are going to serve a purpose of calculations. Calculators are special purpose computers. So because why these are referred as computers? Because normally in computers we will find an input device as well as output device. we are going to find some fixed routines or fixed programs. So which will do some kind of processing operation in similar manner. In calculators also we will be finding some fixed program routines, as well as we will be finding some input devices like keypads, and we will be finding some output devices like luminous displays like 7 segment display, or in modern calculators you will be finding the LCD displays as well to showcase the results to the user. So these fixed program routines are usually stored in the ROM. So like computer, in computer you will be finding the ROM. So whose purpose is to store the fixed program routines. Here also you will be finding a ROM or a memory version, that is ROM. So which is going to store some fixed program routines, and these program routines are activated or initiated by entering the commands like the plus, minus. These are the operator codes. So plus, minus, multiplication, division. So we are going to execute these fixed program routines by entering these commands through the keypads. So usually numerical data will be entered here and necessary mathematical operations are carried out. Okay. Next one is the structure of calculator. So in structure, this is nothing but a block diagram also. This can be called as a block diagram also. So here you are going to find, you are going to get a brief view of the various components that are available in the calculator. Very first device that you are going to see is an input device. The most common input device in a calculator is a keyboard. So keyboard, basically it is nothing but it is a group of key switches, and each key switch is going to represent a digit or an operation. As you can see, you will be finding a group of key switches in the keypad of a calculator. So every key switch is going to represent a digit or an operation, which will be understood by the these key switches are, whenever they are key switches are pressed, or whenever the each key is depressed, it is going to generate a binary code. So that binary code is further sent to the that is the further it is sent to the control section for the future processing operation. So the important thing here is, so as you are going to find many key switches in the keypad like digits or if or an operation, every key depression is going to generate a unique binary code. That unique binary code, why it is unique binary code? Because I expect each key switch to perform or to generate a unique binary code, and that binary code is decoded or it is understood by the processing section, that is the control section of the calculator. And each there is an unique, the same thing is written here, there is an unique code for each key, and the processor can decode it. So you will be finding at the back end, at the front end you will be seeing only the numbers or the operation uh, operations, but actually at the back end, whenever you press a key, it is going to generate a binary code. That binary code is understood only by the processor, not by you. And the processor, it knows very well how to handle that information. So this is about the input device. And next section is the data storage. As we know that data storage, why it is used, data storage, basically it is a storage, means it is going to uh, or it is nothing but a memory. So here all the datas that are entered by the user or the programmer are stored here, even though if there are any intermediate results, or if the results are to be displayed, means we need to store them in some memory. So generally this is a section where all the entered data by the programmers, maybe it's an operand code, or maybe they are um, operand codes or operands or operators, all those are stored in the this section, that is memory. And here the same thing is written is, whenever data is entered into the calculator, it must be stored somewhere. So that so that it can be later processed by the arithmetic unit. So that data storage area is generally made up of registers, not registers. This is register. Group of flip-flops will be there. Those group of flip-flops are going to store the data that are entered by the user. And the most important register is an accumulator. So as you can see in the most of the processor, the basic purpose of accumulator is to store the data on the temporary basis. The usually in most of the arithmetic calculations, the accumulator itself will be in a destination register. And the and we expect every processor must have an accumulator for an temporary for storing the data on the temporary basis. And once the result is calculated, the same content or the content of the accumulator is navigated to the display, or it is routed to the display for displaying the result. So this is about the data storage, and it is implemented by the registers. Okay, and next one is the next important unit is the arithmetic unit. This you can say the heart or the brain of the system, because most of the calculations like additions base calculations that are ranging from basic arithmetic to the complex mathematics all will be carried out in the arithmetic unit only. So in basically in arithmetic unit you are going to find the adders. So even though if you want to do an subtraction operation, the subtraction operation is also carried out using the adder circuits only. And in arithmetic unit there is a 1 bit register is associated in the arithmetic unit, so whose purpose is to store the carry bit whenever it is generated in intermediate stage. So if you want to keep a track on carry bit, there should be a single bit register also that is associated with the arithmetic unit. And in arithmetic unit you are going to find the adder circuits. The same thing is written here. Arithmetic unit, as it the name implies, it performs the arithmetic operations. So on which data it is going to perform the arithmetic operations? That the data that is stored in the storage area here. So that data is you can see here the data is flowing to as well as fro in the sense from the memory it is fetching the operands here. Once it does the calculations, once and the result is ready, the result is again stored back into the storage. There is a two-way flow of data here from arithmetic unit to the memory or the data storage. And here it consists of adder circuit. As I already told you, it consists of an adder circuit. Even though if you want to perform subtraction also, then the subtraction operation is also carried out using the adder circuit only in a two complement method manner. And if you want to do a multiplication, then it can be carried out with the successive addition method. And if you want to do, or if you want to carry out the division operation, it is done in with the successive subtraction method. So all these are carried out using the adder circuit, single adder circuit only. Then as I told you, it is going to have one single bit storage register which is included. So the basic purpose of this single bit storage register is to keep a track on carry generated at the intermediate stage. So this is about the arithmetic unit, and this is a very important unit in case of a calculator. You can refer it as a heart or a brain of the system. Next one is the output device. So usually whenever the result is carried out or whenever the result is ready, then the result has to be showcased to the user. How you are going to showcase, how are you showcasing the result to the user? So basically in some calculators may use the luminous displays like 7 segment display or LCD display, or in some calculators there is a facility to print the result as well. So this is an output device which is used to display the results to the user, maybe in the hard copy manner by using some printer devices, or maybe using some luminous displays like LCD or LEDs. I can display the results to the user. That is about the uh, output device. The same thing is written here. The most common output device used in the calculators are printers or luminous displays. such as LCD or LEDs, whatever. So the purpose of output device is to showcase the results to the user whenever the operation is completed. Next one is the important section, that is the control section. So basically the control section, so this is the section where all the programs in the sense, as I while discussing or while introducing the calculators, I told you that calculators are a microcontroller based systems. Microcontroller based system in the sense, they will be having a fixed program routines for every command. For every command means, in case of this control section, you will find something called as ROM. So all fixed programs will be stored here only. So there is a ROM here. So in case of storage, you can see a ROM. So this ROM is going to it consists of the fixed program routines. Means for addition there is a fixed program routine is there. For subtraction there is a again a fixed program routine is there. For multiplication or for division, for every different operation there is a fixed program routine is there. And the purpose of this control section is to execute such fixed program routines. Andra idar artha eno, control section, it is going to identify the operation that a user wants to do, or it is going to accept the commands from the user. Based on the command that is entered by the user, it is going to identify it, and it is going to execute the fixed program routine that is meant for that particular command. So this is about the control section. Control section, it contains the programs which governs the operation to be performed on the data in order to produce the result. The program consists of many binary coded instructions held in the read-only memory, that is ROM. These instructions are read from the program memory sequentially and decoded to perform the required functions. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಯೂಸರ್ ಏನೋ ಒಂದು ಪ್ಲಸ್ ಅಂತ ಒಂದು ಕಮಾಂಡ್ ಎಂಟ್ರಿ ಮಾಡಿದಪ್ಪ ಅಂದ್ರೆ ಪ್ಲಸ್ಗೆ ಅಸೋಸಿಯೇಟೆಡ್ ಏನಿರುತ್ತೆ, ಒಂದು ಫಿಕ್ಸ್ಡ್ ಪ್ರೋಗ್ರಾಮ್ ರೂಟೀನ್ ಇರುತ್ತೆ, ದಟ್ ವಿಲ್ ಬಿ ಇನ್ ದ ರಾಮ್. ಸೊ there should be someone to tell you, there should be someone to tell the calculator to execute uh, from here to execute the fixed program routine. We need the address of that fixed program routine for this addition operation. So this control section will go to that particular program, that particular fixed program routine in the ROM, and it's going to execute it. This is about the control section. And at last is nothing but the power source. So as we need for this, since there are different sections are there, all these sections they need powers, different various range of powers to operate on. So the purpose of this power source is to supply the needed power range to the various sections of the calculators. Usually we will be using a lithium battery, which is a uh, long storage battery anta helbodu. Lithium battery in modern computers, so modern calculators, along with the lithium battery you will be finding the solar panels also. The solar panels, they can be used as an alternative power supply. So ಇದರ ಅರ್ಥ ಏನಪ್ಪಾ ಅಂದ್ರೆ, whenever in the sunlight, if you are working on calculators ಅಂದಾಗ, so in the sunlight the calculators, they make use of the solar panels to uh, generate the power and supply them to the various sections of the calculators. And in absence of sunlight, they make use of the lithium storage battery, which is used in the calculators. So he usually store power source, lithium battery is used to provide the power requirement. Some calculators also, they also may have solar panel to provide a free power in the day. Andra during the day session, they make use of solar panels, and whenever in absence of light or during night or in the low light condition, they make use of the lithium battery which is inside the calculator. Next one is the internal organization of the calculator. So internal organization. So here we will be discussing in brief what are the various kind of registers that are built in into the calculators and how actually the operation is performed. In a detailed way, we will be discussing here. The figure shows the internal organization of the calculator. Here, the first one is the keyboard. As we know that keyboard is an input device. So keyboard is made up of several key switches for uh, those key ಅಂದ್ರೆ ಇದರ ಅರ್ಥ ಏನಪ್ಪಾ ಅಂದ್ರೆ there will be an unique key for each decimal each digits as well as for the operations. You will be finding several key switches here, and each key depression is going to generate a binary code. That binary code is further encoded by the encoder and it is sent to the control sections for the further processing. And you are going to find a multi-digit 7 segment display here, so which is nothing but an output here. And you will be finding a power source, a power supply. Generally the power supply will be either a lithium battery, long storage battery, or in some modern calculators you will be finding the solar panels associated with them. So those solar cells are going to provide and are they can be used as an alternative power supply during the day. And the heart of the system is nothing but the adder or subtractor circuit. So there is an clock source that is provided here. So this is used to synchronize all the various units operations here. So this is going to generate a clock frequency that ranges from 25 hertz to 500 kilohertz. 25 hertz to 500 kilohertz. So this point you are supposed to write. It is going to generate a clock frequency from 25 hertz to 500 kilohertz. So this is a range of frequencies that a clock is able to generate here. So here the keyboard encoder, the keyboard encoder, it translates every key depression into a binary equivalent code, and the control circuitry is going to store it. The control circuit is also store it in the display register. You are going to find the various registers here like display register, operand register, and accumulator register, as well as X registers. We will see the importance of all these registers one by one. Whenever a particular let's say whenever a particular key is pressed here, so that keys and equivalent encoded data will be sent to the display register control section. From control section further it is sent to the display register. In the display register, the purpose of display register is to store the uh, data data, encoded data that is entered by the user from the keyboard, and the same information is sent to the 7 segment display via a decoder. What kind of decoder this is? So usually uh, this is a BCD to 7 segment decoder, because we will be getting a binary code here, and we expect its equivalent 7 segment code which is sent to the display register here. This is the decoder which converts this is nothing but it is a 4 is to 7 decoder. 4 is to 7 decoder in the sense every BCD code, which is nothing but a group of 4 digits, it takes the 4 digits as an input and produces a 7 7 7 7 7-bit decoded data. That decoded data is sent to the 7 segment display for the displaying purpose. Then next, after entering the once the user enters the first data, very next data he is going to enter is the operation code. That operation code, whenever he enters the operation code, then the whatever the first data that is entered by the user, it has to be routed or it has to be stored somewhere else, because the next data is to be displayed on the display andaga, next thing is to be displayed on the data andaga. So again agata display register will route its value to the operand register. Again operand register, this is a temporary storage register here. So this is going to store the copy of the display register which is entered in the previous operation. So whenever he enters an operation code, then first the operation code will be stored in the display register. So once the display register find it as an operation code, then immediately it is routed not into the operand register, instead it is routed into the X register. X register ಅಂದ್ರೆ ಇದರ ಅರ್ಥ X register, this is a register kind of storage, so which is used to store the operation code like plus, minus, multiply, division, whatever. All the operation codes are stored in the X register. Then once he enters the next data, again the same thing goes into the display register. For the next time, again it will go into the it is copied into the operand register. Like this it repeats. Then what is the purpose of accumulator here? So once the user enters the command, like plus or minus or whatever, then the control section, it has to recognize that command and it has to execute certain stored programs, which are fixed programs that are in the ROM. So let's say user, if he has entered 2 plus 3, 2 plus 3, we expect the result to be 5. Okay, what happens is, whenever he enters whenever he enters 2, as soon as he enters 2, that is encoded and it is stored in the display register. The copy of the display register will go into the 7 segment display and 2 is displayed here. After that, he is going to enter the operation code, that is plus. So once he enter plus, then the same thing is again encoded, and now I expect the previous content of the display register. Previous content ಅಂದ್ರೆ ಏನಿತ್ತು 2, that 2 is copied into operand register. One of the operand is stored in the operand register, 2 is copied into operand register, and plus this is not an operand, this is an operation code. That copy will go into X register. The purpose of X register is to store the operation code. Okay, next again he will enter one more operand, that is 3. That 3, it goes into the display register. Means in operand register the value 2 is there, and in display register the latest value, that is 3, is there, and the operation code, it is stored in the X register. Okay, now the control, as soon as he enters the equal to command, then the control section, it will identify the operation code that is there in the X register, and whenever it recognizes this operation code plus, immediately it is going to search for the fixed program routine in the ROM. ROM will have certain fixed program routines. So using the instruction register and using the address register, it is going to fetch the program that is written for the addition operation, and it is going to execute it through the adder or subtractor circuit. So this adder or subtractor circuit, it has to get the two operands. One operand it will get it from the display register, another operand it will get it from the operand register. Andre 2 ಮತ್ತು 3, the 2 and 3, once it gets them from the display and operand register, it does the addition operation. The result is computed as 5. That 5, it will go directly into the accumulator register. Now I hope you understood the purpose of accumulator register. The accumulator register, that is used to store the result after the computation. Once the result is stored in the accumulator, the same copy of the result is again sent back to the display register, and whatever the content of display register is there, that is 5 is there, the same 5 value is displayed in the 7 segment display, and now the result 5 will be displayed in the display register. Here you can see these scanning lines are used to there are multiplexed 7 segment displays are there. So these scanning lines are used to turn them on in the alternative fashion, one by one. all segments won't be turned on simultaneously. They will be only one 7 segment displays will be activated at any time, but these scanning lines are going to activate them in a faster rate. So that's why, due to the persistence of vision, it appears like the result is getting displayed continuously, but the result won't be displayed continuously. It will be displayed in the faster rate. So that's why it appears like, due to the persistence of vision, it appears like uh, the result is being displayed continuous in a continuous manner. I hope it is clear. So 2 plus 3 equal to 5 ಈ ಆಪರೇಷನ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ, ಫಸ್ಟ್ ನೀವು 2 ಅಂತ ಎಂಟ್ರಿ ಮಾಡ್ತೀರಿ. 2 ಎಂಟ್ರಿ ಮಾಡಿದ ತಕ್ಷಣ ಇಲ್ಲಿ 2 ಅಂತ ಎಂಟ್ರಿ ಮಾಡಿದಾಗ 2ಗೆ ಈಕ್ವಿಲೆಂಟ್ ಬೈನರಿ ಕೋಡ್ ಜನರೇಟ್ ಆಗುತ್ತೆ. ಜನರೇಟ್ ಆಗಿ ಅದು ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ಗೆ ಬರುತ್ತೆ. ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ನಿಂದ ಎಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ, 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇಗೆ ಹೋಗಿ 2 ಅಂತ ಡಿಸ್ಪ್ಲೇ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಅವನೇನು ಮಾಡ್ತಾನೆ, ಯೂಸರ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಎಂಟರ್ ದ ಆಪರೇಷನ್ ಕೋಡ್ ಪ್ಲಸ್ ಅಂತ ಎಂಟ್ರಿ ಮಾಡಿದಾಗ ಅದು ಕೂಡ ಎನ್ಕೋಡ್ ಆಗಿ ಆ ಎನ್ಕೋಡೆಡ್ ಡೇಟಾ ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ಗೆ ಬರುತ್ತೆ. ಈಗ ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ನಿಂದ ಎಲ್ಲಿಗೆ ಹೋಗ್ಬೇಕು, ಅದು ದಟ್ ಹ್ಯಾಸ್ ಟು ಗೋ ಇನ್ ಟು X register, because the purpose of X register is to store the operation code. ಪ್ಲಸ್ ಅನ್ನೋದು ಇಲ್ಲಿ X register ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಅವ ಏನು ಮಾಡ್ತಾನೆ, ಸೆಕೆಂಡ್ ಡೇಟಾ 3 ಅಂತ ಎಂಟ್ರಿ ಮಾಡ್ತಾನೆ. ಸೊ 3 ಅಂತ ಎಂಟ್ರಿ ಮಾಡಿದಾಗ ಅಗೇನ್ 3 ಫ್ರಮ್ ದಿ ಕೀಪ್ಯಾಡ್ ಅದಕ್ಕೆ ಈಕ್ವಲೆಂಟ್ ಎನ್ಕೋಡ್ ಆಗಿ ಅದರ ಕೋಡೆಡ್ ಡೇಟಾ ಇಲ್ಲಿ ಬರುತ್ತೆ, ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ನಾಗ ಬರುತ್ತೆ. ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ ಪ್ರೀವಿಯಸ್ ಕಂಟೆಂಟ್ ಏನಿತ್ತು 2 ಅಂತ ಇತ್ತು, ಅದು ಎಲ್ಲಿಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ, ಆಪರಂಡ್ ರೆಜಿಸ್ಟರ್ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಅದರ ಅರ್ಥ 2 ಅನ್ನೋದು ಆಪರಂಡ್ ರೆಜಿಸ್ಟರ್ಗೆ ಬಂತು, 3 ಅನ್ನೋದು ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ಗೆ ಬಂತು. ಅದೇ ಸೇಮ್ ಕಂಟೆಂಟು 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇ ಕೂಡ ಹೋಗುತ್ತೆ. 3 ಅಂತ ಇಲ್ಲಿ ಡಿಸ್ಪ್ಲೇ ಆಗುತ್ತೆ 7 ಸೆಗ್ಮೆಂಟ್ ಡಿಸ್ಪ್ಲೇ ಒಳಗೆ. ನೆಕ್ಸ್ಟ್ ಅವ್ನು ಈಕ್ವಲ್ ಟು ಅಂತ ಪ್ರೆಸ್ ಮಾಡ್ತಾನೆ. ಈಕ್ವಲ್ ಟು ಅಂತ ಪ್ರೆಸ್ ಮಾಡಿದಾಗ ಅವಾಗ ಈ ಕಂಟ್ರೋಲ್ ಸರ್ಕ್ಯೂಟ್ ಏನು ಮಾಡುತ್ತಾ, ಈ X ರೆಜಿಸ್ಟರ್ನಾಗ ಏನು ಆಪರೇಷನ್ ಕೋಡ್ ಐತೆ ಅನ್ನೋದು ನೋಡ್ಕೊಂಡು ಅದಕ್ಕೆ ಕರಸ್ಪಾಂಡಿಂಗ್ ಇರುವಂಥ ಏನು ಫಿಕ್ಸ್ಡ್ ಪ್ರೋಗ್ರಾಮ್ ರೂಟೀನ್ ಇರುತ್ತೋ ರಾಮ್ನಲ್ಲಿ ಅದನ್ನು ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡುತ್ತಾ. ಆ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಬೇಕಾದಾಗ ಬೇಕಾದ ಡೇಟಾನ ಒಂದನ್ನು ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ನಿಂದ ತಗೊಳುತ್ತಾ, ಇನ್ನೊಂದನ್ನು ಆಪರಂಡ್ ರೆಜಿಸ್ಟರ್ನಿಂದ ತಗೊಳುತ್ತಾ. ರಿಸಲ್ಟ್ ಕಂಪ್ಯೂಟ್ ಆಗಿ ವಾಪಸ್ ಆ ರಿಸಲ್ಟ್ ಎದ್ರಾಗ ಬರುತ್ತೆ, ಅಕ್ಯುಮುಲೇಟರ್ಗೆ ಬರುತ್ತಾ. ಆ ಅಕ್ಯುಮುಲೇಟರ್ ಸೇಮ್ ಕಾಪಿನೇ ಎದಕ್ಕೆ ಹೋಗುತ್ತಾ, ಡಿಸ್ಪ್ಲೇ ರೆಜಿಸ್ಟರ್ಗೆ ಹೋಗುತ್ತಾ. ರಿಸಲ್ಟ್ 5 ಅಂತ ನಿಮ್ಗೆ ಏನಾಗುತ್ತಾ, ಡಿಸ್ಪ್ಲೇ ಆಗುತ್ತಾ. ದಿಸ್ ಇಸ್ ಹೌ the calculator is going to work, and this is an important question for 10 marks in your examination. Thank you.